Good afternoon, ladies and gentlemen. This was our first data analysis practice, and this is an example of something that you are most definitely going to have to be doing on your written part of your AP test. They're going to give you an experiment, and they're going to ask you all kinds of questions about it. This one starts off with a bunch of background about the clownfish and how they have a dynamic with the males and females. They talk about how they work, and then they go into some details about how males and females behave, stating the largest female is in charge of the group. Only the largest male and female get to mate and take care of the young. Both parents care for the eggs by tending them, and then they tell you each different type of tending that they have. Okay. And it goes into how the males can step up and become females, and then it goes into food availability. So fish also experience shifts in how much food is available. So some years there's lots and they have many young, and some years there's difference. So Tina did some research on the fish, and then we see her data here below. Now, for each of these, this is super important, you are going to see a scientific question. So her scientific question was, and they're going to give it to you, how does food resource availability influence parental care in clownfish? All of your information, your claims, and everything should be coming back to this scientific question. Okay, so to make a hypothesis, well, you could have said, I think it's going to increase parental care. I think food availability will increase parental care. Food availability will decrease parental care because they have lack of energetic resources. So it's some sort of a proposed explanation for what you think is going to happen. How do you think that food resource availability will influence their care? Okay, now we have some graphs. So this is where we all took kind of a south turn here, where it's a little bit off. So they show you the sex of the fish, which is male and female, and then they had the number of mouthing events. So what was our testable question again? What was our question we were looking at? How does food resource availability influence parental care in clownfish? Okay, so if we look at the males, this male has a full belly with the orange. This one has a half a belly, so they were hungry. And then they show the number of mouthing events for males. What we can see here is that in males, we do not see a gap between error bars. We see a presence of error bar overlap. That is telling us that there's not a statistically significant difference between males that have eaten and males that haven't in the amount of care they're going to provide. What about females? Well, if you look closely, there's a space between these two error bars. So we see that there is not error bar overlap, meaning there's a statistically significant difference in females between ones that have full bellies and ones that don't. So let's look at a student's claim here. So let's do a look at one of these claims based on our first graph. Okay, so let's go to our first one. So this student said the parent fish with a full amount of food spent more time mouthing the offspring than parent fish with half the amount. Because we have a problem here. They didn't separate the males and females. Okay, they didn't say, because we're not comparing males to females, we're comparing full bellies to empty bellies. Okay, and then they did reference the error bars, but it doesn't really reference if they're talking about males or females or what. So there's no overlap in error bars, which means there is statistically significant difference between parents with full rations and parents with half rations. So they're not stating here what error bar overlap they're actually looking at, right? So it's a little bit cloudy here. So let's look at another one. Now, if you didn't get a claim and you didn't get a evidence from the graph that supports that claim, that makes sense, the reasoning point is not gainable. Okay, let's look at this next student. Male and female, okay, good, they separate it. Male and female spend more time mouthing their eggs with more food. Okay, not quite right based on our first graph, because we saw a difference for those males. If you remember when we looked at that graph, we saw the males didn't really have a difference, a statistically significant difference. So the number of mouthing events is statistically significant between each event. Well, I don't see a male with overlap and a female without overlap here. So this person didn't quite earn the point. Let's look at the second one though. Males spend much more time fanning their eggs when there is an abundance of food in the environment. Females don't fan. Okay, wait, this claim looks like, this second claim here looks like it might go with the graph that was there. So let's look back at our second graph, okay? Ooh, males fanning. Okay, full-bellied males, look at them. Lots of time fanning. Hungry males, not so much time fanning. And look at this huge gap here. So for males, we see a statistically significant difference in the amount of fanning, whether they have a full or empty belly. Females don't fan. This person is going to be getting a point for that claim. So let's look back at what they said. So our person said, males spend much more time fanning their eggs when they're, yes. Females do not fan. This would have been a point. There is a statistically significant difference between the male and female fanning events. Good job. There's no difference. There's no difference in female events. We had no data for females. Let's look at their third claim. Males fish spend more time tending to their eggs with an abundance of food compared to females. Oh, we're not comparing male and female. We're comparing full belly. Male with full belly to male with un. So they get a point for this claim too. Let's look at their reasoning. Reasoning is a biological reason. Why would we see this, right? So for claim 2, where they earned their point, let's look and see if they got reasoning for that. Males can fan their eggs more due to an abundance of nutrients. Yes. Okay, so this person got a point across the board here for claim, evidence, and a good reason. Okay, let's look down here at our last student. Okay, so graph 1. Food resource availability does not influence parental care in the clown anemone fish by males, but it does negatively influence parental care in females. Bang. That is perfect. They talked about the males, they talked about the females, they referenced full belly, not full belly, and they gave a statement. Okay, evidence. We always go to the graph. Evidence. Remember CERs from our lab write-ups? We always go to the graphs. Evidence, the error bars overlap in the data set for males, meaning there is not a statistically significant difference, but error bars do not overlap in female data, showing a significant difference. Perfect. Okay, this is a perfect response. Now, reasoning. Reasoning has to come from why. Why would we see that? So for claim 1, this claim is reasonable because there's a noticeable difference, but not statistically. And this would be because mouthing would use very much energy and is a needed measure to clean the nest for males and for females. It makes sense that the data is different because they don't do much to mouth to begin with. The low energy makes sense that they would do even less. Perfect. Very, very good. Biological reason. All right, graph 2. Food resource availability does negatively influence parental care in clownfish by males, but does not influence parental care in females. So let's look back to what the graph looked like for graph 2. Males, yes, statistically significant difference. Females, no data. Okay, so let's look. So error bars do not overlap in the data set for males, meaning there is a statistical difference. And error bars do not overlap in females, but there's also no data there, so we can't make a conclusion. Reasoning, the claim is reasonable because the fish have half the energy to do normal processes, so a significant drop in fanning is expected in males. Data in female is inconclusive. Very, very good. Okay, graph 3. Let's look at graph 3. Graph 3. Okay, I see in males statistically significant difference because we do not have overlap of error bars. Females, not statistically significant because full or half empty belly, we see overlap, meaning no statistical difference. All right, let's see what our last candidate wrote here. Okay, they said, claim 3, food resource availability does negatively influence parental care in the clown anemone fish by males, but it does not influence parental care in females. Perfect. The error bars do not overlap in the data set for males, meaning there is a statistically significant difference, and the error bars do overlap in females, meaning there is no difference. Excellent job. Claim, reasoning. The reasoning is because there's a significant drop in tending time due to lack of energy, but it is impressive that the overall tending time is not as drastic as the fanning time for males. Females' tending time being not significantly different is reasonable because all they mostly do is pick up the male's slack, which is kind of what we're seeing in these graphs. They are picking up their slack, right? I think the males are the workers in this situation. Okay, so guys, claim, evidence, reasoning. Please, please read the scientific question. How does food resource availability influence parental care in clownfish? And then do our claim is based on that scientific question. Okay, so our claim has to have something to do with this question. Okay, not just kind of randomly making a claim based on what you're seeing. Okay. All right, look at the graph. If we have error bars, please examine overlap, please. That's a very important part of this. Okay. All right, and then last but not least, did the data support her hypothesis? Go back and look at the data. Was it supported or not? Okay, and then give us a nice explanation. What new question can be tested? This is up to you. Come up with a new question you want to test. And then what future data should be collected? How are you going to measure it? Okay, so I would measure this by counting how many times the fish did this, or seeing if so for example, if my testable question was, what does the temperature of water, how does that affect tending time in males and females? And then I would say, how would I collect that data? I would measure how many times they tend to their eggs with different temperatures of water. Okay, so you are definitely going to see something like this when you take your AP test. If you need to correct this, please go back, redo yours. Look at error bar overlap, fix it, and send it back to me, okay? All right, guys, have a nice evening.